Hey everybody, Ben Bosley here with the Meter Guys, and based on your survey results and more importantly, our interactions with students across this country, most of you don't understand how your LEL sensor reads and why it sees gases the way it does, and more importantly, understanding the numbers that your meter puts out. So over the next couple sessions, we're going to talk about your LEL sensor, how it works, why it works, and understanding the numbers that you'll see on your meter when you are air monitoring. So for this meter minute, it's all about the numbers and your LEL. All right, so here we go. Understanding the numbers on our LEL, or also known as your combustible gas sensor. We're primarily going to focus on the cat bead sensor, which is what most of you have out there in the response industry, whether you have MSA, IS, Draeger, Ray systems, doesn't matter. Most of those have the technology of a cat bead sensor. So the first thing we need to define is some of the terms. Most of us meter to the lower explosive limit. That means we do not care about the upper explosive limit. So when we are looking at a gas, our meters are telling us how close we are getting to the lower explosive limit. And that is an important thing. Now the question is how do they tell us that we're getting close to that? So there's two ways of measuring that. The first way we measure that is percent of the LEL. Right? That's how a lot of us see the world. Now, those of us who have gas meters that are provided by either a gas supplier or your local utility company, they might buy you the ones that they're using. They use percent by volume, which is a completely different math. So you have to understand how your meter is seeing the world. And then to make it even more confusing, some of your meters will go from percent to the LEL and might actually change over to percent by volume. So man, let's make that even more crazy. We're thoroughly confused about the math and what's going on. So let's first responder proof this. So we're going to talk about methane, a gas that we're all pretty familiar with. So first thing you need to understand is that most of us have a cat bead sensor and do percent to the LEL. So I'm going to speak to that primarily. So your meter sees things in parts per million. So the room that you're sitting in, I want you to think of 1 million things. I don't care whether they're BBs, softballs, marbles, don't care what it is, but put 1 million things in that room. Well, 1% of a million is 10,000, okay? As long as you can hold on to those numbers. All right, now follow me here. The LEL of methane is 5%. So I need 5% of those marbles in that room to be methane marbles, and I am at the LEL. Well, 5% times that 10,000, remember 1% of your meter is 10,000 parts per million. So 5 times 10,000 is 50,000. If I have 50,000 of those marbles in that room, methane marbles, guess what? You are at 100% of the LEL. Your meter will say 100, or will it? We'll talk about what your meter says actually when it reaches the LEL in the next meter minute. Don't forget to follow that one. But anyway, 50,000, that is my LEL. My meter starts to alarm at 10%. Well, 10% of 50,000 is 5,000. If I hit 5,000 marbles in that room of methane, my meter will say 10% and start to go into the low alarm. If I hit 500 marbles in that room that are methane, guess what? My meter says 1. That's the simple math that we just need to understand about how our meter sees the world in percent of LEL. All right, so that was the down and dirty math for our LEL sensor. If you guys have any questions, please feel free to reach out. But more importantly, if you want your responders, if you want your crews, if you want your employees to get in front of the thumb, to be safer, to understand the technology that they have in your hand, reach out to the Meter Guys. This is what we do. So at the end of the day, we need to make sure that we know our technology, know our meters, know the math, and know why meters matter. And that's your Meter Minute.